Welcome to AI on AI, the show where we peel back the layers of cutting-edge research. Today, we're talking reinforcement learned teachers, or RLTs, straight from that ArcSieve bombshell, 250608388.
Thrilled to be here. This framework flips the script. And from a boardroom view, it's like going from commissioning a symphony to simply handing musicians the score they must teach.
Exactly. And under the hood, the trick is dense reward shaping, RSS and RKL, so the model isn't blindly exploring, it's getting token-level feedback every step.
Right. And they generate the explanation with the solution already in context. Think Master Chef handed the finished dish and asked to film an instructional video.
Let's ground that one fintech I advised swapped a 70 billion parameter teacher for a 7 billion RLT and cut GPU hours by 82%. Same accuracy on compliance doc parsing.
That's eye-popping from a capital allocation standpoint. The 80-20 rule lives on. 20% of the parameters delivered 80% of the business value.
Before we sprint, quick refresher. Traditional RL reasoning uses one-hot correctness, sparse reward, needs the model to stumble on the answer by chance. RLT hands over the answer and focuses on explanation quality.
And the math matters. RSS is AVG-log solution tokens log pit token. That AF set to 0.01 prevents the model from hiding a low probability gotcha token.
RKL then aligns the teacher's distribution with the students when the solution is masked. DKL average plus alpha max. It penalizes hallucinated leaps, so every step is learnable.
In business terms, it's like Six Sigma for knowledge transfer, reducing variance in step-by-step instructions so junior LMs don't misinterpret.
Building on that, they chose GRPO as the RL algorithm. Policy only, Monte Carlo returns, group size 64. No value network, so training stays lightweight.
But here's a curveball. Why not ditch RL altogether and just score explanations offline with a heuristic?
Ah, that's tempting. But RL lets the model iteratively refine explanations. The policy gradient nudges wording toward what the student actually internalizes. Without it, you're back to handcrafted filters.
Love the debate. Now tech leaders ask me, do dense rewards really scale? Any thoughts?
I benchmarked the 7B RLT on a larger 32B student. Distilled performance jumped 3 points on GPQA. That says the reward signal generalizes across parameter gaps.
Plus, out-of-distribution transfer, zero-shot countdown arithmetic beat direct RL on the task. Shows the teacher's explanatory skill is task-agnostic.
Strategically, this unlocks reusable teaching assets. A Fortune 500 retailer could spin a single RLT to train dozens of departmental models: supply chain, pricing, demand forecasting.
And each spin-off SFT run costs maybe $200 in compute versus six figures for rerunning RL on giant models. CFOs smile.
Let's dive deeper into that KL term. If you ablate it, the teacher collapses into parroting the answer verbatim. Student gains evaporate. I tried it. Accuracy tanked from 49% to 34%.
Conversely, drop the min-max reductions, and you get verbose rambling, token soup. Logically correct but bloated, hurting latency in production.
Speaking of production, memory footprint matters. They trained at 16,384 tokens context, half of Quen's max, so distillation traces stay tractable.
But inference teams can still raise the window during generation if they want extra reasoning, thanks to VLM streaming. No code changes.
Culture eats strategy for breakfast, Drucker said. Here, reward shaping eats compute for lunch. Aligning incentives beats throwing flops at the wall.
Quick case study. A call center analytics firm used an RLT pipeline to spin a 13B bilingual assistant. They cut human labeling by 70%, ramped to market in 6 weeks.
Another detail, reference model sync every 32 steps with 0.9 mix-up prevents the policy from drifting too far. That stabilizes training even with small batch sizes.
And they didn't need pricey verifiers. Student log probs act as a self-contained critic, elegant and cheap.
There's a subtle philosophical twist here. The teacher never solves anything solo, it just explains. Is that a limitation?
Maybe, but explanation is the scarce resource. Anyone can check a solution. Few can teach it clearly.
Plus, regulators love traceable reasoning. A bank using RLTs can show auditors exactly how the model derives mortgage risk scores.
Contrary view. If you feed the teacher bad ground truth, you bake errors into every student. Garbage in, garbage amplified.
True, but you can ensemble multiple RLTs, rank by reward, and drop outliers. Pseudo cross-validation for explanations.
From a portfolio standpoint, that redundancy is cheap insurance.
Let's zoom back to technique. Any insights on scaling laws?
Early data hint at sublinear parameter efficiency. Doubling teacher size gives 20% student lift. So bigger isn't always better. Better rewards trump size. I'd add context length scaling. Extend to 32K tokens, and you can capture multi-document chain of evidence tasks. Think legal reasoning.
And that opens a market. Legal tech is eager for small deployable models that can cite sources.
One caution, long traces inflate storage. A heuristic we use, compress with sentence piece then re-expand on the fly, saves 60% disk.
For execs, the takeaway is simple. Invest in teachability, not teacher girth.
We're nearing time. Lightning round. One heuristic listeners should steal.
Reward what you can measure at token granularity. Course rewards mislead.
Distill early, distill often. Teacher checkpoints degrade fast in RL.
Treat explanations as product features. Optimize for latency and readability, not just accuracy.
Budget backward. Set the TCO target first, then pick model sizes that fit.
And remember, the best way to predict the future is to teach it. With RLTs, you literally encode tomorrow's expertise.
Mic drop moment. Thanks to all our experts, and thanks to you for listening. Until next time, keep learning, keep teaching, and stay curious about your AI. Welcome back to part 2. Let's pop the hood on RLTs and talk concrete implementation, deployment wrinkles, and yes, how to translate all that into board-level KPIs.
All right, nuts and bolts first. Most teams start with a vanilla 7B chat model, slice in a 2-epoch SFT prep so it understands the new prompt schema, then flip to GRPO with our dense RSS plus RKL reward. Code-wise, it's about 300 lines of top TRL.
I'd add a trick. Stream generation through VLLM with paged attention. That alone shaved inference latency during training by 40%, which matters when you're sampling 64 explanations per prompt.
From the business side, the CFO asks, what's the dollar burn? On 8 H100s, we clocked 125 RL steps in under 3 hours, so roughly $150 of cloud GPU time. Compare that with 6-figure bills from 70B parameter RL runs.
And because the student acts as the reward model, you skip spinning up a separate critic. Simpler orchestration, fewer microservices to monitor, lower DevOps overhead.
For execs, think of it as moving from heavy industrial presses to desktop 3D printers. You decentralize capability creation.
Deep dive moment, those KL terms. We compute DKL token student online. If the divergence spikes above tar, we backprop straight away. No need for separate penalty schedules.
Exactly, and pay attention to F12 point core 1. It looks tiny but stabilizes gradients. I experimented with point 1 and gradients exploded on long proofs. By the way, a healthcare analytics client used that KL threshold as a governance hook. If divergence exceeds policy, they flag the trace for human review, meeting HIPAA interpretability mandates.
Quick implementation hack. Store solution tokens in a side-channel tensor. Avoid string concat in the generation loop. Nets a 7% throughput gain.
And what gets measured gets managed. The team kept a live dashboard of average RSS and trace length. When length drifted above 1.5 times baseline, they knew the teacher was starting to waffle.
Speaking of length, we found a sweet spot around 60 to 80 think tokens. Below that, students miss reasoning motifs. Above that, marginal learning returns taper off. Classic diminishing returns curve.
Here's a contrarian twist. Everyone optimizes for accuracy, but in our A/B tests, explanation coherence correlated more with downstream user trust than raw answer rate. That plays directly into customer-facing chatbots. A telco rolled out an RLT distilled 13B model and saw NPS jump 9 points because users liked the step-by-step bill breakdowns.
Implementation nugget: use mix-up reference syncing beta at 0.9 to prevent catastrophic shifts. Skip it and you get oscillations that look like an ECG on a bad day.
The 80-20 heuristic again. 20% of hyperparams drive 80% of stability. Group size, KL weight, and reference mix-up. Lock those early.
Let's drill RL reward telemetry. Log RSS, RKL, and total R in Prometheus. Anomalies in RKL often precede toxic or nonsensical traces, so you can auto-throttle.
And don't forget curriculum shaping. Start with medium difficulty problems so the teacher learns broadly useful patterns. Then anneal in diamond questions to stress test logical jumps. Business application. An EdTech platform used that staged curriculum to generate personalized tutoring explanations in 5 languages. Content teams estimate a 10 times lift in course production speed.
Multilingual angle reminds me, RLTs transfer zero-shot surprisingly well. Prepend a few language tags in the prompt and the teacher self-adjusts, so you avoid separate RL runs per locale.
That's strategic gold. Single investment, global reach.
Quick code snippet for listeners.
Reward SS equals sol logprobs, sol logprobs.min.detach. Reward nofmiel aftal ax spatch. Reward equals reward SS lambda KL.
And wrap that in torch.nograd, except for the policy path to keep memory in check. Now deployment. Students fine-tuned on 17K traces tend to be 400 megabytes smaller after weight pruning because explanations act as regularizers. That slashes edge device memory budgets.
On the ROI front, a logistics SaaS shaved 90 seconds off route planning LLM calls. At 4 million daily queries, that's an annualized savings of $2.3 million in compute and driver idle time.
Speed is addictive, Bezos once quipped. Lower latency lets you embed reasoning in interactive loops that were previously synchronous bottlenecks.
One caveat. If your solutions are noisy, the teacher becomes a misinformation superspreader. Implement checksum-style validators on solution data.
Building on that, we tested ensemble teachers voting via mutual RKL. Disagreement drops by 37%, akin to bagging in classical ML. I see your point, but ensembles do raise inference cost. CFOs may balk unless you cache traces aggressively.
True, but you can amortize by reusing the cached explanations across multiple student training cycles. Think of them as evergreen assets.
We're almost at the finish line. Any closing heuristics for CTOs planning a proof of concept next quarter?
Start minimal 5K QA solution triples, 512 batch. Watch the reward curves. If they plateau in under 30 minutes, your pipeline's healthy.
Automate trace ranking via reward percentiles. Keep top 30%. Discard bottom 20%. Sample middle for diversity.
Map technical metrics to dollars early. Latency, GPU hours, and regulatory interpretability all have direct P&L impact.
And finally, schedule a teach-back day. Engineers present what the student model learned. If they can't explain it, neither can your auditors.
Remember, you don't have to swing hard to hit a home run. If you got the timing, it'll go. Align the timing of RL, SFT, and business objectives, and the ball just flies.
Perfect note to end on. Thanks to all our experts for translating research into actionable playbooks. For listeners, the repo links and template scripts are in the show notes. Go build your own RLT pipeline, and as always, stay curious. All right, let's close with a rapid-fire recap. What's the single most important takeaway you want our audience to remember?
For me, it's the paradigm shift. Stop training teachers to solve problems. Train them to explain solutions. That judo move flips the exploration burden on its head.
Technically, dense RSS minus that RKL rewards beat sparse correctness because they provide gradients from step 1, so even a 7B model can guide a 32B student. Small torch, big wildfire.
I'll add the ops angle. 3 hours on 8H100s versus weeks on megaclusters. If you can't beat the 80-20 curve, change the curve.
Strategically, RLTs turn reasoning traces into reusable IP. Once generated, they amortize across languages, markets, and compliance audits. Asset, not expense.
Unexpected gem? Explanation coherence outranks raw accuracy for user trust, optimized for clarity, and the KPIs follow.
Beautiful. Now a quick next frontier round.
Dynamic duo training. Teacher and student co-evolve. Teacher adapts to the student's blind spots in real time.
I'm itching to push context length to 32K and watch multi-step proofs blossom without truncation. From the boardroom, we'll see vertical-specific RLT bundles, finance, legal, healthcare, sold as plug-and-play reasoning engines.
And don't forget self-RLT loops. A model explains to itself, distills, and iterates. Autodidactic LMs on the horizon.
Last but not least, guardrails. Checksum validators and ensemble voting must scale with capability. Power without safety is a liability.
Time to land the plane. Here are today's highlights. We unpacked the core innovation of reinforcement learned teachers, a dense reward framework that collapses cost but boosts downstream accuracy. We dissected technical levers, KL regularization, mix-up reference syncing, trace length sweet spots. We heard business wins, 10 times content generation, multi-million-dollar latency savings, 9-point NPS jumps, and we scoped future plays. Co-training, longer contexts, vertical packs, and self-learning loops. As Peter Drucker said, the best way to predict the future is to create it. With RLTs, you've got the blueprint. Now it's your turn to build. Thanks for tuning in to AI on AI. Until next time, keep experimenting and keep questioning.